Good morning. Today we are going to discuss about last class note that I have given, differential equation of wave motion. It will be a second order differential equation. How we are going to get? Previously we know that when the displacement of a plane progressive wave along positive x-axis direction, then this general equation will be y equal r sin 2 pi by lambda into vt minus x. So by differentiating two times equation number 1, this equation number 1 with respect to t, here write on, we can found d square y by dt square is equal to minus 4 pi square by lambda square v square y. Let that equation number 2. Similarly, if we are going to differentiate equation number 1 with respect to x two times, we can found minus 4 pi square lambda square into y. Now you compare this equation number 2 and equation number 3, then we can found this much. This is common in both the cases. So instead of 4 pi square by lambda square, I can put 4 pi square lambda square into y. 4 pi square lambda square into y. Instead of this, I can put d square y by dx square. So comparing equation number 2 and 3, d square y by dt square is equal to v square into d square y by dx square. This is the differential equation of wave motion in one dimension. Okay. Then we have to discuss about if a longitudinal wave moving in a solid or a rod, that is, this is a rod, then what will be its velocity? In our previous class we have been discussed that a longitudinal wave is moving in a elastic medium or in a gas, then what was its velocity that we have been derived. So this is the derivation that we have to find out if a longitudinal wave will be moved in a solid or a rod, then what will be its velocity. Actually in your syllabus it is not there, but in short we are going to be discussed in short. So what is written here? Consider a thin rod having its thickness along the direction of having its length along the direction of x-axis. That is, suppose this is a rod which is elongated along x-axis direction. Let PQ, this is the portion, this portion is called as the PQ. So PQ is be a small element of the rod having a length of del x, and a longitudinal wave. Then when a longitudinal wave means you can think about the sound wave, means suppose this is a rod, rectangular rod, this is a rectangular rod, solid rod, means suppose this is a iron rod, not a scale, plastic scale, consider this is a iron rod. So here if we are going to give some disturbance, then the sound will be travel from this to this end, so that traveling speed we are going to be find out. Okay. So now let a longitudinal wave means suppose a sound wave propagated through that rod, let element PQ be displaced to P dash Q dash. The element whatever we have been considered initially PQ, that suppose it is displaced to new position P dash and Q dash, this. Okay. The displacement of P equal to y. Let the displacement of p to p dash is y. Okay, but the displacement of q to q dash will be y plus dy by dx into delta x. तुम कहो सर ये तो पी क्यू तो एतिकी लेंथ एठू एतिकी लेंथ तो पी जदि पी डैश को वाई डिस्प्लेसमेंट कला क्यू टू क्यू डैश जिबा पई तो सेतिकी वाई डिस्प्लेसमेंट होबा कथा आपण को एठी कहउचंती वाई प्लस समथिंग. Why I am telling that y plus something? Because when wave is traveling from this side to this side from a particular position to another position, so this we are considered initially pq element. So from p to q it will be vary or its length will be vary like this, del y by del x. So as the gradient of displacement is dy by dx per unit length, then for delta x how much displacement will be extra? That will be dy by dx into delta x. मैं आउ थरे कहूची ओडिया रे ता माने एटा तमरो p टा होची इनिशियल बा तमरो स्टार्टिंग एंड एंड एटा होची एंड. एटा गोटे मुंडो एटा आ गोटे मुंडो बा एटा गोटे साइड एटा आउटे साइड. तो जो डिस्टर्बेंस एठी दिया हला एठी तो डिस्टर्बेंस दियाला p टा p डैश को पळला q टा q डैश को गला किंतु p टा p डैश को गले जदी y होची q टा q डैश को गले हमर y हबा कथा हमकु जणा पडुची. किंतु एठी कोन होची हमकु कंसीडर करा होची दिस इज वन टाइप ऑफ ए रबर सीट को मु टाणी देबी जदी मु एठी टाणी देबी जदी टणा है गला एठी मु जदी ता फोर्सफुली टाणीबी ताले q टा p टा जेतिक डिस्टेंस ट्रैवल करबो q टा ताठू अधिका डिस्टेंस ट्रैवल करिवो. बुझिला ता माने एटा गोटे रबर सीट. देखो ए जो रड टा इज वन टाइप ऑफ ए रबर भलिया तेणु करी जेतेबेले हमर एई पटरु किछि साउंड वेव बा एनर्जी दिया हबो बा पटरे लेफ्ट हैंड साइड रे इट विल ट्रैवल टुवर्ड्स द राइट साइड. सो एटी लक्ष्य कर एई पॉइंट होची ए पॉइंट होची ए रेड डेटा होची ए. वेट गोटे सेकंड मन कर रेड टा हला ए पॉइंट ब्लैक टा हला बी पॉइंट. ओके सो जेतेबेले गोटे एनर्जी ट्रांसमिट हबो लेफ्ट टू राइट की ता माने इट विल एक्ट लाइक ए स्ट्रेचेड स्ट्रिंग. सो तुम लक्ष्य कर मु जदी टिके एटा तार इनिशियल पोजीशन. सो इफ आई एम गोइंग टू स्ट्रेच समव्हाट राइट you just see how much the B point, this black point is displaced in right hand side, A point displaced less than that. See you just mark wherever मु जो धरी जे सेइठू मार्क करो तुम जानि परिबो सेइठी मार्क करथाओ. देखो मु स्ट्रेच कले B पॉइंट अधिका बाट पळोछि as compared with A. तुम लक्ष्य कर जानि परिबो हैला. तो ए पॉइंट जति की डिस्टेंस ट्रैवल करछि बी टा ताठू अधिका डिस्टेंस ट्रैवल करछि सेही एका फोर्स अप्लाई कले बस आदर केवल एती कांसेप्ट. सो हाउ मच दैट विल बी ए ग्रेडियंट मींस along y axis along x axis रे along x axis एटा x axis तो along x axis रे मनकर रेट टा हो स्टार्टिंग पॉइंट रु x axis जते जीबी सेते तार जो स्ट्रेच हवार कैपेसिटी बढ़ी बढ़ी का जीवो. मन कर देख एटा एई ब्लैक पॉइंट टा को जदी मु एठी नेबी आसी कोठी एठी नेबी माने ब्लैक पॉइंट टा एठी न नै मु एठी नेबी देखो मु सेई एका फोर्स देबी सेकंड ब्लैक पॉइंट विल बी स्ट्रेच मोर देन द फर्स्ट ब्लैक पॉइंट एंड मोर देन द रेड. ता माने मु एई रेड पाखरु एटा हो स्टार्टिंग पॉइंट कोड जोड़ी मु धरिछि सेइठू मु आड़ को डाहाण को जत्ते जत्ते जीबी टुवर्ड्स x, how much I have to be move on this rod, then its stretching capacity will be increased. Now that means the dy by dx will be there. The change of stretch means dy, change of y, y means along this axis, change of y means this side. p टा एठी थला p डैश गला चेंज का थला y हला, तेन को change of y along x axis is a positive, काहेकि ना मु जत्ते x axis को आड़ू जाउची तो स्ट्रेचिंग कैपेसिटी सेते बढ़ी बढ़ी जाउची. देखो ए ब्लैक पॉइंट सेकंड ब्लैक पॉइंट ता अधिका स्ट्रेच हबो फर्स्ट ब्लैक पॉइंट थारु. देखो यस सर नो एबे ठीक से जानि परिबो. मु एठी कोन करली ना गोटे लाइन रे रेड को रेड ब्लैक ए फर्स्ट ब्लैक को ब्लैक रखिली, फर्स्ट ब्लैक को ब्लैक रखिली. मु गोटे फोर्स रे गोटे निर्दिष्ट फोर्स रे राइट की टाणु छी. देखो सबुठारु लिस्ट सबुठारु कम डिस्प्लेस हबो रेड टा, ताठु अधिका हबो एटा, ता सबुठारु अधिका हबो एटा. देखो डिस्प्लेस गोटे निर्दिष्ट फोर्स देली, देखो फर्स्ट ब्लैक पॉइंट ता ओरिजिनल पोजीशन रो अधिका बाट जाइछ ना नाही. आउ तो देखो एट थला, देखो मु गोटे निर्दिष्ट फोर्स रे तो करछि, ताने फर्स्ट ब्लैक पॉइंट रो दाग कोठी ना एठी, सेकंड रो एठी, रेड रो एठी. ता माने स्ट्रेच कले फर्स्ट ब्लैक पॉइंट एठी के आसला, सेकंड टा एठी के आसला, रेड टा एठी के आसी. ता माने देखो सेही एका फोर्स रे रेड जेति की डिस्प्लेस हिची ता परटा राइट हैंड साइड रे था ता पर पॉइंट ता ताठु टिके अधिका हिची, ता पर पॉइंट ता ताठु अधिका हिची. ता मीन्स स्ट्रेचिंग कैपेसिटी इज इंक्रीजिंग और gradient of stretching capacity has been increased when we have to move along x axis. ता माने dy by dx is positive. जदि एटा नेगेटिव ही था ताहले आडू काडू कमी था, से जहाँ भी हो हमरो dy by dx we got the positive quantity. So if dy by dx is positive, that means rate of increasing of y with respect to x is a positive. So for this length पे केते एक्स्ट्रा इंक्रीज हबो, ता माने एठी रेड टा एठ हो जाय गला, एठ एतिकी जिबा कथा तम आम कहया अनुसार कन एतिकी जिबा कथा, यार भी एतिकी जिबा कथा. आ जो एक्स्ट्रा इंक्रीज हैला से इंक्रीज टा केते हबो ता तार जो डिस्टेंस एठ एतिकी डिस्टेंस ऊपर से निर्भर करछि. रेड फर्स्ट रेड रु सेकंड ब्लैक पर्यंत थिया डिस्टेंस ऊपर सेटा निर्भर करूछि, डिपेंड्स अपॉन दैट. So dy by dx into delta x means this distance between p and q. So q will be displaced to q dash of a distance q plus dy by dx into delta x. Okay. That's it. एथरे आउ किछि कांसेप्ट नाही. एतिक सॉरी. So increasing length is pq is equal to in the net increasing length of the element pq. Net increasing length of pq will be that will be displacement that will be y plus the final length is y plus dy by dx delta x minus y will be, this will be the increasing of length. So now longitudinal strain is nothing but increasing length by original length, that will be dy by dx delta x by delta x dy by dx. This is called as the longitudinal strain. Now let F be the force acting on the section P dash, therefore the tensile stress is given by tensile stress is equal to F by A. A is the area of the cross section of the rod. Young's modulus of the elasticity of Young's modulus of elasticity, that is this y, large y, y of the material of the rod is tensile stress by longitudinal strain. So stress is equal to F by A by dy by dx. So it will be will be that implies F is equal to y into A into dy by dx. So एठी F टा कौन? F टा होगी the so called restoring force. That means if if I am going to apply a force, then it will be displaced, na? So that force is expressed in pressure, that is called as the F by A. That is stress. Stress is nothing but force by area. So hence force on the section P dash will be how much? F Q dash, it will be F plus dF by dx into delta x. As we have to if we have to move towards the right hand side, as the length is increasing, corresponding point to length is increasing with the same force, that means it is behaves that each and every point feels, or each and every point have their own different force. That means this is the red point. At the red point have one force. It experienced one force, and at this point it is experienced another force. This point it is experienced another force. Only for that it is displaced this much. This is displacement more than this. This is displaced more than this. So here for this point, what will be the force? The force will be the initial force F plus the gradient of force del F by del x into delta x. That is right to left. Right to left. Why it is right to left? Because whenever we have to stretch a string, then it will be try to restore. It will be restore its original position. So how much we have been force we have been applied here. So at this point, one restoring force will be backward. So only for that it is written that right to left. So this force whatever we are discussing, this is the restoring force. Okay. So now net force on the element is F plus del F by del x delta x minus F, which will be also right to left. The so called restoring force is del F by del x into delta x. So d by dx, the F how much we got initially? We got this one, we have to put here, and delta x, then y a d square y by dx square delta x. Mass of the element is nothing but volume into density. The volume is nothing but area into length a into delta x. This is the density. The restoring force will be mass into acceleration. Force will be mass into acceleration. This will be a delta x rho is the mass, and acceleration is nothing but del square y by dt square. Okay, so here is the restoring force, one expression, this one. Here is the restoring force, another expression. If I am going to compare this one, or I am going to equate these two equations, then I will find d square y by dt square. D square y by dt square is equal to y by rho d square y by dx square. This one. So now, if we are going to compare with differential equation, whatever we have been got initially, that is differential from the differential equation of wave motion to d square y by dt square, b square by d square y by dx square. Then if I am going to compare this, then it will be d square y by dt square. It will, you write, it will be v. It will be better. There it is v. V is the velocity of the wave. V square d square y by dx square. So now if I am going to compare this and this, then v is the velocity. V square is equal to y by rho. So v is equal to y by rho root over, which is nothing but called as velocity in a rod. Okay. Thank you.